Alright, how's everybody doing today? This is Mr. Muscarella coming at you, and in this video, part 2, we're going to take a look at finding exact values of expressions involving inverse trig functions. So a little continuation of what we looked at before. Now again, we've got to remember what the difference is between these types of functions, what they're asking for. In the first one, sine of pi over 3, that asks us to go ahead and give a ratio. The answer we get is going to represent the ratio of two sides of a right triangle. Whereas if we have an arc sign on the outside, that's where we're trying to determine the angle measure. Now in part 1, the focus on that one, the outside function was a regular trig function, sine, cos, tan, or cosecant. The answer to those problems, we always got a ratio, or sometimes it was just a decimal. But here in part 2, the outside function of our composition is going to be an inverse trig function, which means all the answers that we're going to get are going to be angles. All right, so we're going to do two quick examples here, and that'll be it for this video. Now what I want you to do first is go ahead and draw 4 coordinate planes, kind of like I have right there, to get us started with this first problem. So we're going to go ahead and find the exact value of our cosine of sine of 3 pi over 4. What I want you to do first is write down this piece, ASTC. That's something you should always remember, and that gives you the sign of where each trig function is going to be positive for the big three, sine, cosine, and tangent. And of course the reciprocal functions would also be positive in the same quadrant. Now next we're going to go ahead and draw where sine of 3 pi over 4 would be, and that would be up here in quadrant number 2. So what I'm going to do is just do this in my second quadrant right here, and I'm going to write 3 pi over 4 in that spot. Now one of the things I want you to pay attention to, this inside function, we want sine of 3 pi over 4. And the sine of 3 pi over 4 here in this quadrant, in quadrant number 2, that's going to be positive. So since a sine of 3 pi over 4 is positive, that's going to help me out when I deal with the arc cosine piece. Now the domain restriction for arc cosine, so remember it, and I'm going to go ahead and draw half this unit circle right here, is going to be between 0 and pi. So again, going back to ASTC, I'm going to use this to help me figure out which one of these two quadrants, either quadrant 1 or quadrant 2, my final answer is going to be in. In arc cosine, since sine of 3 pi over 4 is positive, I want our cosine to also be positive. And if I look at the two quadrants that's a possibility in, that is only possible up here in quadrant number 1. So the answer that I'm going to get is going to be over here in quadrant number 1. So here's how we come up with our answer. First, we're going to go ahead and draw the 3 pi over 4. So we're moving on to our last piece right here. 3 pi over 4 is there. Now in quadrant number 1, over in this spot, what we're going to do to find out what that angle is, we're actually going to find the reference angle for 3 pi over 4. So to go from 3 pi over 4 back down to the x-axis, or back down to where pi is, I have to travel a distance of pi over 4. So that whole distance, because both of those are going to have the same value, they're going to be the same distance right here, this spot right here and this angle right here, they would both be the same as far as the distance to the x-axis. So when you evaluate arc cosine of sine of 3 pi over 4, that is going to be just pi over 4. So again, we went through several steps. First, we figured out ASTC. We've got to recognize that. Second thing, we had to recognize where our inside function, what the sign of that is going to be, whether it's going to be positive or negative. The third thing, we took a look in our domain restriction for our inverse trig function, which in our cosine's case is limited to quadrants 1 and 2 from 0 to pi, and I want the sign of our cosine to match the sign of sine of 3 pi over 4, whether it's positive or negative. And then I just found the reference angle. So that was how we did that problem. It's pretty straightforward, but you just have to be able to take your time and do each one of those things, and I think you guys will be good with it. Now let's go ahead and try one more example here. And this time, again, we're going to start out, we're going to draw ASTC. That's going to go in our first one. Next, we're going to go ahead and draw where sine of 5 pi over 4 is, and that is down here in quadrant number 3. So 5 pi over 4 in quadrant number 3, my inside function is sine, which means 5 pi over 4, the sine of that is going to be negative in quadrant number 3. So sine of 5 pi over 4 is negative, which means I want arc cosine, that's going to be negative in quadrant number 2 here, because in quadrant number 1, of course, all trig functions are positive. So my angle that I'm going to end up with is going to be somewhere up here in quadrant number 2. So to find that, again, I'm going to have to find that reference angle. So if I'm at 5 pi over 4, now to get back to the x-axis, or where the pi is, I travel a distance of pi over 4. But I have to go up another pi over 4 to get to actually to where that angle would be in quadrant number 2. So really what we're just going to do is take 5 pi over 4 and we're going to subtract, because we had to move in that direction. We're going to subtract 2 pi's over 4, which I know could be reduced, but we're just going to keep that so it's a nice common denominator. So 5 pi over 4 minus 2 pi over 4 is just going to give us 3 pi over 4. So the arc cosine of sine of 5 pi over 4 is just going to be 3 pi's over 4 is going to be that angle. Alright, so that's it for this video. By now you should be able to find exact values of expressions involving inverse trig functions, and I think you guys will rock this one out from now on. Alright, best of luck, have a great day, and I'll catch up with you later. Peace out.